So yesterday we have started with this software measurement. So we have briefly discussed about the direct measures and indirect measures. Direct measures are quantitative in nature. You can explicitly specify them in terms of a number. Say 10 length of a bolt. Example, we have seen length of a bolt. It means some say 2 centimeter. So, and the indirect measures includes the quality of a bolt produced, which are very descriptive, which are the quality is good. So the parameter of a good, the definition of a good may vary from person to person. Okay, so this is a general example. So in terms of software also, we have discussed about the direct measures related to the software process and indirect measures related to the software process. Direct measures related to the software process includes the lines of code that you have written that can be counted, execution speed can be counted, measured, memory size required for the execution can be counted, can be identified, exclusively identified. Defects reported over certain period of time can be exclusively counted and can be maintained, reported explicitly. Indirect measures. So indirect measures again related to the quality, how the functionality is good or bad, the quality is good or bad, the complexity, efficiency, reliability, maintainability, and other abilities, which are either which may be derived from primary measure or direct measure, or are subject to or is subject to the person who is assessing the quality. Okay, so let's move further. The attributes of effective software metrics. The attributes of a effective software metrics. What are the attributes of a effective software metrics? Effective software metrics. So hundreds of metrics have been proposed for a computer software, but not all provide practical support to the software engineer. Okay, there are hundreds of metrics available, but not all are good for all kind of a project. So we have discussed like formulation. We have discussed few parameters in the last lecture. That first step for the software metric is formulation. The formulation means identifying the correct suitable software metric, which is the metric which is suitable to assess the quality of a module or a software of your program. हर मेट्रिक हर जगह अवेलेबल रहेगा, हर मेट्रिक हर जगह काम में आएगा, ऐसा नहीं है. फर्स्ट वी नीड टू फॉर्मुलेट, वी नीड टू केयरफुली चूज कि किस क्वालिटी के किस मेट्रिक के आधार पे हम हमारे मॉड्यूल को एनालाइज करना चाहते हैं. एंड देन वी स्टार्ट कलेक्टिंग डेटा रिलेटेड टू दैट मॉड्यूल एंड देन एनालिसिस, इंटरप्रिटेशन एंड फीडबैक इज देयर. This we have studied in last few slides. So these are few attributes. Like a metric should be simple and computable. It should be relatively easy to learn how to derive the metric, and its computation should not demand inordinate effort of time. Simple hai? So suppose the lines of code. So lines of code can be easy. It is a very simple metric. It is easily computable. Okay, the metric should be simple enough to understand, and it should be easily computable. It should not take the subtle amount of time. I mean, it should not take suppose एक metric आपने choose किया, and to calculate that the value or the data for that metric, अगर आपको उसमें एक 15 मिनट का समय लग रहा है, then it is not a good metric. It should be easily countable. Empirically and intuitively persuasive. The metric should satisfy the engineer's intuitive notions about the product attribute under consideration. A metric that measures module cohesion should increase in value as the level of cohesion increases. Empirically and intuitive intuitively persuasive. The meaning is that it should follow the notion about the product of a software engineer. ऐसा होता है ना कि सपोज आपने कुछ एक सामान लिया है और उसके सामान के लिए उस प्रोडक्ट के प्रति आपकी एक धारणा आपने बनाई है कि नहीं, ये इस तरह से काम करेगा या इस तरह से वो थोड़ा आगे बढ़ेगा, अगर हम उसमें इस तरह से कुछ काम करते हैं तो इस तरह से उसका एक आउटपुट आएगा. एक होता है हमारा एक सोचने का तरीका होता है कि अगर मैंने कोई एक नई गाड़ी ली है तो वो इस तरह से काम करेगी, अगर मैं ऐसा कोई ऑपरेशन करता हूं तो इस तरह से आउटपुट आएगा। तो ये जो इस तरह से जो हम सोच रहे हैं, जो एक यूजर के मन में, जो एक सॉफ्टवेयर डेवलपर के मन में है, so whatever metric that you choose, it should correctly represent that what you can say, the intuition of engineer. It should be consistent and objective. It should be very consistent. ऐसा नहीं होगा कि that particular metric is जैसे कल हमने पढ़ा था कि if the value of that measure is increasing in nature, so अगर वो metric डिफेक्ट को रिप्रेजेंट करता है, देन इंक्रीज इन द मेट्रिक वैल्यू शुड, इट मींस दैट एरर हैव इंक्रीज्ड, सो इट इज कंसिस्टेंट। अगर मेट्रिक की वैल्यू कम होती है तो एरर्स हैव डिक्रीज्ड, इट इज कंसिस्टेंट, इट इज ऑब्जेक्टिव। ऐसा नहीं कि हमने जो ये मेट्रिक हमको लगता है अच्छा होना चाहिए तो हमने वो मेट्रिक चुन लिया। द एवरी मेट्रिक दैट यू चूज, इट शुड कम विद अ प्री डिफाइंड ऑब्जेक्टिव। ओके, सो ऑब्जेक्टिव, व्हाट यू आर गोइंग टू मेजर, दिस मेट्रिक identifies the parameters related to whatever is your quality objective, quality goal. That's why this particular metric is suitable for the analysis of this module. So it should be simple, it should be easily computable, it should link up with the intuition of engineer, it should be consistent, it should be objective. Consistent in its use of units and dimensions. So units, consistent in its use and dimensions. Okay, the mathematical computation of metric should be measures that do not lead to bizarre combination of unit. For example, multiplying people on the project team by programming language variable in the program result is a suspicious mix of unit that are not intuitively persuasive. You can either count what is the size of project team, how many people are working. You can also count how many programming variables that you have created in a program. These two can be your separate measures. Can be based upon these two separate measures, you can derive suitable metric. But when you say कि मैं number of people into variable programming language multiply करूंगा और उससे कुछ metric बनाऊंगा, then it is not a good practice. It is programming language independent. It is programming language independent. Metric should be based on the requirement model, design model, structure of the program itself. They should not be dependent on the vagaries of programming language, syntax or semantic. They should not be dependent upon the programming language, syntax or semantics. An effective mechanism for high quality feedback. The metric should provide you with information that can lead to a higher quality end product. Whatever हम metric क्यों choose कर रहे हैं, because for the metric we can derive some, we'll be able to compare it with some indicator, and with the help of that indicator we should be in a position to gain some insight whether we are moving right, whether we are moving wrong, how much we are deviating from the proposed plan, or are we on a track. So this kind of quality parameters we are trying to assess from the metric. So a metric should be simple, it should be competitive, it should come with a particular objective, it should not be ambiguous, it should clearly notify the intuition of an engineer, it should give a proper feedback, it should be programming language independent, and so on. So function based metric, function based metrics. So function point. So in the function based metric there is a concept of function point. We denote it as FP. Function point, we denote it as a FP. Can be used effectively as a mean for measuring the functionality delivered by the system. So using function point, we can effectively measure the functionality delivered by the system. We'll see what are the functionalities and how we are going to measure. Now, using historical data, the function point metric can then be used too. There are three things that using function metric you can perform. First, estimate the cost or effort required to design, code and test the software. Using function point, you can estimate the cost or the effort required to design the particular module, code a particular module and test a particular module. predict the number of errors that will be encountered during testing. You can predict the number of errors that may happen, that may occur during the testing. You can predict the value of that error, that particular number. Forecast the number of components and the number of projected source line in the implemented system. So this function point can tell you that the number of components required for the completion of this particular module will be 5, 10, 100, whatever is the number of component, and the projected line of code that is needed, because based upon some historical data. It considers historical data into account, applies certain logic related to the current environment, and it tries to provide you cost or effort required for various activities, the errors in the testing phase, the components needed, and the lines of code needed for the development of a new module. Now, function points are derived using relationship based on countable measure of a software information domain and qualitative assessment of a software complexity. So basically it is derived from these 5 parameters: number of external input, number of external outputs, number of external inquiries, number of internal logical files, and number of external interface files. These are 5 things. Now let's try to visualize this with the help of this diagram, this particular data flow model. Okay, so this is a data flow model for safe home software. This is a safe home software. Some kind of alarm based or sensor based system is there, and it will safeguard your home. This is one module of a safe home software. Now with this diagram given, we need to identify these 5 parameters. Number of external inputs. So number of external input, name is clear that you are giving input to the system. How many inputs you are, this is your system. Safe house user interaction function, this is your system. These are your inputs, these are your outputs, you can consider like this. So how many inputs you are giving? See, password is one kind of a input. If you press the panic button, it is a kind of input. If you activate, deactivate something, it is a kind of input. So inquiries are different. See, inquiries are different. So we clearly visible that you have given 3 external inputs. So value of this particular parameter, number of external input in this application is 3. Now next we want to identify the inquiries. See here the inquiries are there, number of external inquiries, these parameter. So in this example we have number of inquiries are 2. One is zone inquiry and another one is the sensor inquiry. So number of value for this external inquiry parameter is 2. External inquiry means you are not giving some input, you are simply inquiring something. Like on ATM, when you go for checking the last transaction or balance inquiry, you are actually not performing any transaction, you are not giving any input to the system for any transaction, you are simply inquiring. So the inquiry is 2. So this is done. Then let's take the next example, that internal logical files. Internal logical file is the logical grouping of data that resides within the application boundary and is maintained via the external input. Some kind of internal file which helps in working the system. So this is the system configuration file. See here. This is a system configuration file. So system configuration file, it resides inside the system. As and when you provide some inquiry, some kind of input to the system configuration data, appropriate action is taken and appropriate output will be shown onto the screen. So how many internal logical file is there? One internal logical file, 2 inquiry and 3 inputs are there. Then Next is number of external outputs. Number of external outputs. Number of external output means here you can say that a message is given to the user or some kind of a sensor status is changed from green to red, red to green, some kind of a status which will give you some indication to the user. So two visible outputs we have given to the user. So the number of output is 2. Here the number of output is 2. Internal logical file is 1. Number of external interface files. Number of external interface files. So external interface file is logical grouping of data that reside external to the application but provide information that may be used of the application. So here we have this test sensor. Test sensor is external to the system, but it helps you in testing the working of the functionality. Some kind of zone setting is there. Zone 1, zone 2. You can logically divide the entire building into various zones. So the north side of the building is in zone 1, the south side of the building is in zone 2. Okay. Then here monitoring and the response of system. It is external to the system. Some kind of alarm alert is there. Some kind of activation, deactivation is there. So in total we have 4 external interface files. We have this external interface file as 4. So now since we have identified the value of all these 5 parameters from this diagram, now this is the function point computation formula. This is a function point computation formula. So function point is equal to count total into 0.65 plus 0.21 into summation of fi. So this is the formula given. And based upon this formula we want to calculate the function point. Okay. Now this is the weighting factor. It is standard for the system. Either it is system is of simple, it is a simple system you are trying to develop. It is an average kind of a system, or it is a complex kind of a system. So these are values which are fixed, which are considered as a baseline values for these 3 kind of a system. Now count. Whatever count you have calculated, you will put those count here. So number of external inputs are 3, number of external outputs are 2, external inquiries are 2, internal logical file is 1, external interface file is 4. You put these values here, and based upon whether the kind of a system is simple, average or complex, you multiply the count with the corresponding value. If your system is simple, so 3 into 3 is 9. Likewise, you calculate and multiply. So here we have considered this particular system as a simple system, and appropriate we have identified the count total. So 3 into 3 is 9, 2 into 4 is 8, 2 into 3 is 6, and likewise, and addition of these 3 is the count total, that is 50. So this count total value we have substituted here 50. So 0.65 plus 0.21, and this is the value of summation of fi. Based upon this, if you apply this formula, you get a value 56. So your function point value, you have what you are trying to calculate? You are trying to calculate function point. So function point formula is count total into 0.65 plus 0.01 into summation of fi. Count total you have calculated. 0.65 plus 0.01 are static terms. So depending on that you have calculated, you have derived an answer that is 56. Now based upon this 56 value, this is the interpretation of that 56 value. What does that value 56 actually mean for a software engineer or a project manager? So based on the projected FP value, based on the projected function point value, that is 56, derived from the requirement model, the project team can estimate the overall implemented size of the safe home user interaction function. Assume that the past data indicate that one FP translates into 60 lines of code. Okay. an object-oriented programming language is used, and that 12 function points are produced for each person per month of effort. So this historical data provides the project manager with important planning information that is based on requirement model rather than preliminary estimate. Based upon this function point we have calculated from the design model. Okay, in external inputs, output, inquiries, logical, interface file, all these parameters are there in the designing phase in the data model that we have seen. Okay, so देखिए, assume further that the past projects have found an average of 3 errors per function point. Assume that an 3 errors per function point. तो पुराने प्रोजेक्ट ने ये बताया कि एक फंक्शन पॉइंट के लिए 3 एरर्स आए थे. सो फॉर दिस पर्टिकुलर टाइप ऑफ अ प्रोजेक्ट आपका फंक्शन पॉइंट 56 है, तो एक फंक्शन पॉइंट के लिए 3 एरर्स, तो 56 फंक्शन पॉइंट के लिए कितने एरर्स? तो these many number of errors you can expect to occur in this particular project. 4 errors per function point during the unit testing. So 4 errors per function point. So for how many errors for a 56 function points? 60 lines of code, 12 function points are produced for each person per month. So one coder, 1 month can produce, can use 12 function points. So for how many person per month needed for 56 function points? Project scheduling. So software project scheduling is an action that distributes estimated effort across the planned project duration by allocating the efforts to specific software engineering tasks. Now scheduling. Schedule kiya in the sense, first you have estimated the efforts required to complete the individual tasks in the particular software project. Okay. After estimation, if you distribute the estimated effort across the planned project duration by allocating the efforts to the specific software engineering task. आपने estimated effort estimate कर लिया, and then you have assigned your team, and a workload has been given to all the members of a team. This is particularly known as scheduling. आपने schedule कर दिया, timeline schedule कर दिया, लोगों को काम assign कर दिया. This is a scheduling करना. During early stages of project planning, a macroscopic schedule is developed. Macroscopic मतलब a broad level of schedule, because it is in early stages of project planning. A macroscopic schedule is produced. Macroscopic means overview, overall, क्या कहना चाहिए, broad level of schedule is there developed. This type of schedule identifies all major process, framework, activity, and the product functions to which they are applied. So macroscopic schedule means analysis will be there, development will be there, coding will be there, testing will be there. This kind of macroscopic schedules are there. As the project gets underway, जैसे जैसे project आगे बढ़ता है, each entry of macroscopic schedule is refined into a detailed schedule. So design is one schedule. Okay, so in design there would be a further macroscopic schedule, मतलब more detailed level of schedule. Who will do it, how it will do it, how long will it take, what will be the output. So in this particular time frame we need that to be finished. All this kind of multiple action, multiple tasks, multiple responsibilities in that particular activity is noted down, and it is scheduled properly. The scheduling is there during the early phase of the software development. A broad level of schedule is there. As and when software development process moves ahead, each broad level activity is further divided into macroscopic, or activities further narrowed down, refined down, and a macroscopic, the minute level of schedule is also prepared and assigned. Scheduling for software engineering project can be viewed from two rather different perspectives. In the first perspective, an end date for the release of computer-based system has already been established. End date, schedule मतलब इसका end date क्या रहेगा? It has been established. The software organization is constrained to distribute effort within the prescribed time frame. We are starting it now. The end date is already been decided. So based upon this available time frame, let us further divide the schedule. This is the first aspect. The second view of software scheduling assumes that rough chronological bounds have been discussed but that the end date is set by software engineering organization. तो पहले इनका ये कहना है सेकेंड अप्रोच कि रफ बाउंड्स आर देयर, पहले हमने रफली बाउंड्स बता दिए हैं, ऐसा ऐसा लग सकता है, but actual end date will decide later on. So these are the two ways, two perspective from which this scheduling can be thought of. Effort is distributed to make best use of resources, and an end date is defined after careful analysis of the software. Simple है. Whatever number of resources you have, you will distribute it very carefully to meet your quality requirement, and end date is defined after careful analysis of the software. If you define an end date before doing a thorough analysis, and definitely if the complexity is increased, complexity is more during the development phase, definitely there are chances that you miss the release date, and missing the release date is not a good practice. Unfortunately, the first situation is encountered far more frequently than the second one. Unfortunately, the first situation arises more frequently because it is practical in nature, that the client says that I need a software in next 1 year. So end date is already defined. So you need to schedule it. You need to schedule internal activities accordingly, keeping the end date in mind. So first situation you see more often. Second situation you see